Okie dokie. So let's talk about the section that we're in right now. The section we're in, this is section 1.3 of in graphing, trying to figure out those peaks and valleys on a graph. So if I had a problem like, let's say my graph was something like this. So f of x is equal to negative 2x squared plus 6x plus 4. And let's say that this is a, let's go with 2x here, 2x. Yeah, let's go with 2x. I think this will work. Double check my. This will actually work. Should. Yeah. Let's do this one. Okay. All right. Okay. So first and foremost, what you've been doing in your homework is trying to find that peak and valley. Now, just super generically on this problem, what direction is this graph facing?
Out.
Down. Why?
Negative.
Negative out front. The tails go the same direction. It's a power of 2, right? So the tails are both going down. So just super like generic graph. This is what we're looking at. Something like that, right? That's a super generic look to it. I'm not putting anything exact into it. In fact, I'm a little bit too high on the y-axis. It should be hitting 4 on the y-axis. The x-axis numbers, if I factor that thing apart, I can figure where the x-intercepts are. But that isn't the part of your homework today. Right, the homework that you had from Friday, that was your page 175 step. You were gone Friday. That stuff's due this Wednesday, so keep that in mind. That homework was based on finding where the peak and valley is. So finding this location right here, that spot. That's what we're gonna be looking at. That's what you had to do, okay? Now it's nice if you have a generic graph, you can kind of get a sense for it. If you know where the x-intercepts are, you can pick the point right between them. But I want you to actually practice that formula. So let's walk through this. I'm gonna get rid of the graph here in a second. Is there any questions with what your homework was supposed to be doing? I'm gonna come back to this and we're gonna actually graph it later. It's just, right now I don't need it, so I'm gonna get rid of this. All right. Okay, so let's talk about it. Differential quotient. This is the formula that we're using. You have to plug in the x plus h's into everything, then we subtract the original function.
Zane Hackle to the office, please. Zane Hackle.
So you have your original function with x plus h, you subtract your f of x, and then you divide everything by h. This is what you have to do. Now, this is going to be the process that you have to do on every problem. I know it's tedious, it's time consuming, that's why I gave you 5 days to get that assignment done, because it does take time to actually work those problems out. Once you do enough of them, you'll get kind of figured out. I gave you a lot of odds in the beginning, so you can check the back to see if it will give you the right differential quotient. They will not go ahead and solve it out. They just want to make sure that you're getting the right differential quotient in the beginning. I do want you to go those extra steps, solve it, set it equal to 0 and that type of thing. So let's walk through this. So the first step here, taking everything, plug in x plus h into everything. Okay, so that's plugging the x plus h in right away. All right, it's the original function. Anywhere you see x's, x plus h goes in there, and they have to be in parentheses, so don't forget that. Is there a question on the first step? So it's the original function, whatever I gave you, that formula, x plus h substituted in. Now, just like this formula, because again, this is your generic formula, it's telling you what to do, we have to subtract the original function off of it. So we're going to subtract and put in brackets here, parentheses, the negative 2x squared plus 2x plus 4. Okay, because again, you have to subtract whatever the original function is. Last, what goes on the bottom? H. Now, if you're wondering, like, how am I coming up with this? Like, it seems like you're just making it up. No, this is your formula that I'm using. The function with x plus h is plugged in, subtracting the original function off, and dividing everything by h. Okay, questions up to this point? Now again, the whole point of this is to figure out that peak and valley. Where is the highest point, the maximum or minimum on your graph? On this particular problem, it has an absolute maximum, right? There is no point higher than that curve. So we gotta go find it. All right, so let's keep going here. What do I have to do first? What do we do on that top part? What should we do? What's your instincts? What's the math that needs to take place here?
Foil the X and H.
Yeah, we gotta FOIL this thing out. X plus H, X plus H. If there's two of them, you're absolutely right. You do have to FOIL that out. Gotta take care of that first. Leave the -2 out front, don't distribute it in yet. Wait till later. So I'm gonna leave the -2 where it sits, but I'm gonna FOIL these two parentheses together. So it's x squared plus xh plus xh plus h squared. That's FOILing it out first, outer, inner, last. Okay, that was good. Good first step. Let's keep going. What else do I do next? Going across.
Distribute to.
Yep. Distribute this 2 to everything here. So that's 2x, 2h. The 4 stuck around. Now what?
Distribute the negative.
Distribute the negative in the back. That's distributing this. So that's positive 2x squared, negative 2x, and a negative 4. And it's all divided by h. Okay, good. Again, it takes a lot of paper to do this. You know, if this is my homework and they showed me this problem in the book, maybe this is problem number 58, I don't know, then this is what I should see in the homework. Exactly what you're doing there. You're starting out by plugging it right in the formula, going kind of crazy, going as fast as you can. Next step?
Cancel things out.
Not yet. Not yet. We are going to do that next. That's the next.
-2.
Yeah, we got to distribute the -2 now. We got to get this -2 to go through the parentheses here. Then we'll start canceling stuff out. So this is negative 2x squared, negative 2xh, negative 2xh, negative 2h squared, plus 2x, plus 2h, plus 4, plus 2x squared, minus 2x, minus 4. All over h. Not bad. All right, now that you've distributed that -2 into everything in that parenthesis, and we got all this stuff in the back, now cancel stuff out. This is how you know if you're doing it right. Things that do not have h's should cancel out. So like the negative 2x squared, positive 2x squared. Perfect. 2x, negative 2x, 4, negative 4. Everything else has h's. So that's perfect. So I'm left with this. Now, if you want to combine like terms, it's fine. I don't really even require it. It doesn't even matter if you do. All right, so that is everything that has h's left. Now what?
Divide by H.
Divide by h. Okay, so I'm going to divide by h here. I know I'm going kind of fast, sorry. Let me know if I need to slow down dramatically. I get kind of in that rabbit mode. But dividing everything by h. So this is what the differential quotient simplified out to be this. Negative 2x, negative 2x, the negative 2h, and a positive 2. This is what the back of the book would probably show you. That's what they'd leave as. Okay? They showed you what it like simplified down to for the differential quotient. Great. Perfect. That way you can double check. That's why I send out. It's nice to see if you're doing great for those first couple. And there's only a select like 2 problems in that whole assignment that I said, but maybe you should try one that you can't even check. See if you're doing great. Okay, so we're here. Now we have to go those extra few steps. We have to plug in h is 0 and then set it equal to 0. Because I want to figure out when the slope is 0, when we're the top of that curve. And then also h is 0, because h, if you looked at your curve, h is the gap between the highest or lowest point and the distance from it. So like you're going right and left of it. Well, if we bring h to be 0, the gap between, the distance from your highest and lowest point, you bring that gap to 0, you're right on top of the highest or lowest point. So that's kind of what we're doing. It's that spacing. So we're going to make h 0, and we're going to set this function, whatever it is, equal to 0. That's what we're going to do. So h is 0 now, so that term is gone, and we're going to set this thing equal to 0. So this is negative 4x plus 2. We're going to set that thing equal to 0. Sorry, I added the negative 2x and negative 2x really quickly in my head. Sorry. Didn't mean to confuse you there. Okay, questions with how I did that? Now, how do we solve? What do we do? Subtract the 2. And? Divide the negative 4. So if we divide the negative 4, we're going to get x is negative 2 divided by negative 4, which is half. What does that mean? What is negative half? Or what is half? What is that in terms of my problem?
That's a big question.
Good question.
It's the maximum value of the.
Yeah. It's, if you looked at your original problem and you're trying to find that peak or valley, in our case, an absolute maximum, right? That's what we're trying to find. Absolute highest point on my graph. Nothing will beat it, right? It's not like it has a bunch of relatives or there's a bunch of little camel humps. This is the tallest hill on my whole graph. That half is the x coordinate. X was half. That's the coordinate where it happened. So, how do we find the y coordinate?
We're plugging the
Plug it in. Plug that half back into the original problem. And it should spit out the actual y answer. Because f of x means y. So if I plug in a bunch of x's, it'll spit out the y answer for it. This is where a calculator comes in handy. I said you need to be very good with your calculator to take that half and plug it in. So I'm taking negative 2 times, well, half, I'm just going to put 0.5 squared, plus 2 times 0.5, and then adding 4. Well, 4 is here, half times 2 is 1, half times half squared is 0.25 times that, so that's negative, I think it turns out to be negative half. If you add these together, I think you get something like 4.5 or something like that. Is that right? You get 4.5 in the calculator? Okay. Let's try to do it in my head. So. All right. Questions? Now, that's what you're doing in your homework. Now, the book will not give you the rest of it. It won't tell you what your x is, won't tell you what your y is, no matter what. It'll at least tell you what your differential quotient should have turned into. So what you reduce down to. That's what I'm hoping it should tell you in the back. So that's why you kind of know. Because the rest of the stuff shouldn't be difficult. Getting to that differential quotient is the hardest part of this whole problem. All right, questions? All right, now, I've been using a lot of vocab recently, right? We've been talking about absolute maxes, absolute minimums. I want to review those two words with you so you know what absolute is, you know what relative means again. I want to talk about some other basic terms, just so if you hear vocab terms at all, you know what I'm talking about. Increasing, decreasing, you know what range is, you know what domain is, those types of things. That's in this unit, this section 1.3. I want to make sure you know those terms. That's all I want to do today. And then I'll be done here in the next 3 minutes. You'll get about 20 minutes to kind of work today. That's what I want to give you. I have to work. And I'll do the same thing tomorrow. I want to give you about 20 minutes where you can just kind of work on your assignment. Because this page 175, as you can tell, it takes paper. It takes time. You just have to basically just plug and shove. Just try a bunch of these out. See if you can get to those basic concepts. But is there a question before I just kind of start erasing some of this stuff? Perfect. Okay. I'll bring that graph back up here just so you can see it. I need a towel. Where's my towel? Where is it? Okay. Anyway. Okay. So let's talk about the last thing I want to do here. So if I gave you a graph like this. I gave you a graph like that. There's an arrow. Oh, thanks. So, might have sent you an email earlier. Just ignore it. It was just I sent it to everybody at the ground. So, okay. So what you're looking at here, this is a graph. It's got one arrow on the one side. It's got a dot on the other. Let's talk about maximums and minimums. Does this graph have a minimum value on this graph?
Yeah.
Yes. What is it? Roughly.
-2.
-2. Okay. That would be an absolute minimum. So if I asked on this graph, what is your absolute minimum? The lowest point would be -2, right? I don't care that it happened multiple times. Do you see that the graph never goes lower than that?
Yeah.
If there's dots, that's an absolute minimum. I know that there's a couple different spots where it happened, but it's the lowest point. Okay, that's an absolute minimum. Now, is there an absolute maximum to this graph? No. The arrow goes up, right? It will never stop. So there's no maximum. You can't tell me, oh, it's going to hit 1,000. No, it'll go past 1,000 eventually. And you don't want to say infinity. Infinity is not a number, it's a direction, right? So this has an absolute minimum. It does not have an absolute maximum, but it does have a relative maximum. Do you agree that there is a little hilltop there, a little camel hump, right? Where was that little hump at? Where was that peak that it hit? About 2, if you ignore my terrible artistic talent. That's a relative max, or a local maximum. It's not the highest point on the graph, but it was a hilltop. So that's what they call a relative max. So you'd say it's about at 2. You can even tell me the coordinate. Maybe it's -3, 2. You just have to tell me where you think the relative max is. Relative means there could be more than one of them, but it's not the highest point. It's in that graph somewhere. So hilltops are relative maxes, valleys are relative minimums, unless there's an absolute question.
So you go with the relative value if the highest one just goes off?
Yeah, to infinity in kind of a direction. Yeah, you can just, then it automatically just switch to this to a relative and just say there's a relative.
You just go to the second
Yeah.
highest.
Yeah, and then even if, good question, because if there was other values, so let's change up the graph here a little bit. Maybe it did something like this. Like that. Let's switch this to a dot. Okay. All right, let's say it's that. Well, I do have an absolute minimum. Absolute minimum is what? About -1 if you ignore my terrible artistic talent. So the minimum is a -1. The maximum, I don't have an absolute max. Don't have an absolute max. This arrow went up forever. It's never going to stop. It's going towards positive infinity. But on this case, there is a couple relative maximums. You agree that there's a couple hilltops, okay? Well, they would both be considered relative. So you don't have to go to the second tallest peak. You go to all of them. So in this case, what is this? The number 4. That's a 4, and that's let's say it's 1.5. Okay, those are both relative maximums. They're just hilltops. So it's not the highest point. You list off the different hilltops you see. That's a relative or a local, whatever they want to call it. Okay, makes sense? So if I ever ask for a relative max or relative min or an absolute max or an absolute minimum, you just have to tell me which value it hit. If you want to tell me the coordinate, cool. If you just want to tell me the peak that it hit, fine. But those are relatives because there's obviously higher points, so they're not the absolute, but you can tell me the hilltops. Maybe there was maybe this graph did something like this. Maybe it did something like that. Well, now you do have an absolute minimum. It's what, -2? And it has a relative minimum at -1. So you could tell me that. Typically to be a relative max or min, it has to be a hilltop or valley. It can't be a stopping point, like that little point on the left side there, way over here. We don't consider that a relative. Relatives or locals, whatever you want to call them, they're usually it's a very smooth curve to them. There's usually a right and left side to it, so it kind of flows. It's not a abrupt stopping point. So in that case, the absolute would be a -2, that's absolute minimum, and then the relative minimum would be -1. That'd be the next point that you saw down the road. Okay, questions with those vocab terms? Okay, now, this is the tough part. Is there a moment on this graph that is increasing, where the graph is increasing as they go from the left side to the right side?
Yeah.
Yeah.
Okay, do you agree? There is a point.
Yeah.
Is there more than one point where it's increasing?
Yes.
Yes. Okay, on this graph, where graphs increase from left side to right side, this is the moment where I'm increasing from there to there. It was going uphill. Didn't matter if there's an arrow going this way. Didn't matter. As I go from left to right, this thing is increasing. Okay? Then it decreases for a little bit. It stops. Then it starts increasing again to about here. It starts increasing. Then it goes downhill for a little bit. Then it starts increasing again all the way that way. It can have multiple bands of, these are called domains. Domains are x values. That it is increasing. Okay? It increases from, what is that? Jeez, what is this? -8. So it increases from -8 up to about, what is that? 1, 2, 3, 4, 5. Let's say 5-ish. -5. It increases from -8 up to 5. Then it increases from -1.5 up to, let's say 1.5. Increases from there to there. Then it increases from 3 up to infinity, positive infinity. That's called interval note, or that's called, set builder notation, where you're giving me like the list of where x's are that fall in there. There's something we're going to look at in the next unit we're going to do, that we're going to change this notation up, but this is what most people think of as like intervals from here to here. So it's increasing. This is something that a lot of people get tricked up on, and that's why I brought it up in this section. If this side had an arrow, for some reason, it must be just something with the arrow. Some people think that that's not increasing. Yeah, I am increasing. I know this thing is going down this direction, but as I go from left to right, I would actually be climbing uphill. That's increasing. Even though the arrow is facing that way, right? Still increasing. It's going uphill. Then it starts falling down. All right, questions with increasing, decreasing. Domain are x's. Range is y numbers. What's my lowest range number on the y-axis? That's correct. -2, and then it goes up to positive infinity. Range are y numbers. That's just something that I know that, it's in this unit. They just want to be getting used to like what are range, what are domain. Domains are x's. Range are y numbers, y values. The only reason I bring this up is that my calc kids every once in a while really struggle with just identifying range versus domain. They get tripped up on which word means what. So that would be a good idea to cover it now. We'll start mixing it in every now and then so you get better at it if you don't go to Calc 1. Okay, questions? Okay, I'm going to give you the rest of the time. Sorry, I took more time than I expected. So I just want to cover some basic vocab. Page 175, that's due Wednesday this week. So I'll put it back up here on the board just so you can see it. But it's page 175, 57 through 63 odds, and then 66 through 68 all. So there's only really 2 even problems. So all the rest you should be able to go to the back of the book, check to see if you're doing it right. Remember, the back of the book will not tell you the coordinate where the max or min is, so you're going to have to go find that. So they'll at least get you to here. They'll at least tell you what the differential is. There you go.
Oh, I know. Yeah.